Make sure you use like all 4 fingers when trying to make that video. Oh, zoom in, up and down. Is it, oh yeah. Hey, is it lit, Dad? How lit do you think it is? Can you tell, a scale of 1 to 10, how lit is it?
Oh, it's real lit.
Is it?
Watch yourself.
Wait to cross.
Welcome back to another YouTube video with Mr. Collins. We're going to talk about converting forms for quadratic functions. So first we're going to start off with a trying to convert to standard form. So we're going to start off with a factored or intercept form. Okay, that's what we're starting with. We're going to try to convert that to standard. So the factored form we're starting off with is y equals 4 times x minus 7 times x minus 9. The way we have to do this, we have to do order of operations. Multiplication, we got to multiply through. So the way that we set this up is I like to use the area model. Okay, there's a lot of different ways you can go through to multiply. Okay. But I find that the area model helps to keep track the best of the multiplication of terms. Okay? So we multiply each side out separately. Okay? So I get x squared minus 7x minus 9x and then 63 after I multiply some things here. Okay? This information is equivalent to what this was. So now we're going to change it to y equals 4 times x squared minus 16x plus 63. Wait, but how do you get that minus 16x? Well, these two things are like terms, so I combine them to make negative 16x, okay? So again, this is equivalent to this, so I can just substitute it in. And then, all I have to do is distribute the 4 to make that last and final conversion to standard form. It's going to be y equals 4x squared minus 64x plus 252. Okay? And there you have it. This is standard form. Okay? We'll talk more in another video about what these different forms reveal to us about the graph. Okay? Now we're going to go from vertex to standard form. So if we use the same equation, so this is the same equation in vertex form. Theoretically, we should get the same exact standard form equation if these make the same graph. Let's see if we get the same answer, okay? So first I'm going to multiply the x minus 8. This is really y equals 4 times x minus 8 times x minus 8 minus 4. It's really important we do order of operations here, and we're going to multiply the x minus 8s. Okay? I don't recommend distributing the 4 first. You can, but you're liable to make mistakes by distributing to too many of these terms. Okay? So x times x is x squared. X times negative 8 is negative 8x. X times negative 8 is negative 8x. Negative 8 times negative 8 is 64. So now it's y equals 4 times x squared minus 16x plus 64, and then minus 4 on the outside. Okay? Now we've got to set it up just like over there where we can distribute the 4 to get y equals 4x squared minus 64x plus 256, minus 4. When we subtract 4 here, this is going to get us the same equation we got in standard form over here, okay? So all 3 of these, this one, and this one, all 3 forms are equivalent, and they also are reflective of the same graph, okay? Next, we're going to go through how to convert from standard to these two forms. Okay? So let's say we're given this standard form. Okay? Our first step when trying to convert to the different forms is to make sure you look for any kind of GCF here. I see one. I see that the GCF here is 3. I can factor out 3 to make it x squared plus 14x plus, which is 45. Okay? So we can go different ways from here. We can look for to see if we can break it into factored form, or we can look to see if we can break it into vertex form. Let's start with going into factored form. Okay, so here we're going to use what we talked about with the area model. Okay, so we have 3 times x squared plus 14x plus 45. Okay, so using the area model, you can kind of make this little box here. Okay, so I know that the x squared and the 45 needs to look like that. We just got to figure out what dimensions we can create to go here. So what two numbers multiply to x squared times 45? This is the product of the diagonal here, and the sum of to get to 14x. So what two numbers will add to the 14x and then multiply to the diagonal here? Well, we could just look at the different factors of 45. There's 45 and 1. There's 15 and 3. There's 9 and 5. 9 and 5 looks like the one. So it's 9x and 5x. Okay? We're going to factor it now. We got to find the GCF between the rows and the columns. GCF between this row is x, here it's 9, here it's x, and here it's 5. Okay? They happen to be positive here, but it's really important that you check the signs. If you don't check the signs, you might make a mistake that you'll regret. Okay? So now this gives us 3 times x plus 5 times x plus 9. That is our factored form. Okay? So far we've been able to convert the standard form to factored form. Okay? Now we're going to convert that standard form to vertex form. So I'm keeping this with the factor out 3 because the process we're going to go through of completing the square is going to be so much easier having factored out that GCF. Always look to see if there's a GCF, okay? So I'm really going to focus again on this section here. So I have x squared plus 14x plus 45. So thinking in my head, I'm thinking, okay, I have x squared, okay? Then I have to split the x term in half. So splitting that in half makes 7x and 7x. So what would be the missing pieces I have to fill in here to complete it? Well, it's really just the multiplication of these two. So 7 times 7 is 49 would be what we would need to complete the square, okay? But with this expression here, I can't just add a 49 randomly. If I add it to my equation, to my expression, I also have to subtract it. Okay? We can't add something without taking away, okay? So this will help us really change it into that vertex form, okay? So now I have these 3 terms which are going to form that complete square of x dimensions x plus 7 and x plus 7. That's what we want. We want to have equal length and width here. And that's how we get this, okay? And then it's minus 49 plus 45. Because if I added that 49, I have to subtract it too. It doesn't make sense to add without subtracting it. That would completely change the expression if we just randomly added the 49. Now I'm going to combine these like terms to get x plus 7 squared minus 4. Okay? But we're not quite done here yet. Okay? We are not quite done here. The problem is we forgot the 3. Okay? So this step is really important. Notice how I put parentheses on the outside of the entire thing. That is really important because I'm going to distribute this 3 to both separate things. I get y equals 3 times x plus 7 squared minus 12. So here we've converted to vertex, and then here we converted to factored slash intercept form. And there you have it.